Artificial intelligence, AI in short, machine learning, ML in short, and deep learning, DL, are related technologies that are changing the face of how many industries manage themselves and make decisions. They are also taking up an increasingly large part of our lives. The lightning evolution of AI, ML, and DL is here and now. Just name a few examples: spam filtering, targeted online advertisement and recommendation engine, computational perception, such as face recognition, speech, text, social, video, machine translations, autonomous vehicles, such as drones, self-driving cars, AI-generated art, such as music, poetry, and painting. AlphaGo AI beats the world's best Go player. AI is the capability of a machine to imitate intelligent human behavior or simulate any intellectual task. It includes perception, the ability to recognize objects through senses such as seeing, hear, and touch. Search or planning, such as play chess or play Go. Reasoning and knowledge representation, such as Watson on Jeopardy. Autonomy is the ability to move and manipulate objects. Natural language processing, which is focused on natural and intelligent communication. Machine learning is the ability of a machine to learn without explicitly being programmed. Machine learning is a subfield of AI. It is evolved from pattern recognition and computational learning theory. It's closely related to data mining and statistics. Deep learning is a branch of machine learning that specifically focuses on algorithms that construct artificial neural networks, inspired by biological neural networks formed in the human brain. It is a computationally intensive technique that makes neural networks more efficient to create at scale. Explicit functional programming involves composing the problem as a set of functions to be executed, carefully defining the input to each function. With an imperative approach, a developer defines a sequence of steps or instructions and if-then paradigm to accomplish the goal. Machine learning is the idea that there are some generic algorithm that can tell you something interesting about a set of data without you having to write any custom code specific to the problem. Instead of writing code, you feed data to the generic algorithm, and it builds its own logic based on the data. The definition for learning is focused on a very specific and limited problem. It is figuring out an equation to solve a specific problem based on some example data. It is important to remember that machine learning only works if the problem is actually solvable with the data that you have. Types of machine learning problems. Supervised learning. It needs labeled training data and makes prediction for new unseen data. With supervised learning, humans can tell the machine which behaviors are good and bad, and the machines figure out the commonalities to develop multidimensional signatures. Classification is one type of supervised machine learning. Its data is labeled, meaning it is assigned a class, for example, spam or non-spam, or fraud, non-fraud. Example algorithms are support vector machine, SVM, decision tree, boosting, random forest. Another type of supervised learning algorithm is a regression, in which data is labeled with a real value. Think floating points rather than a label. Examples that are easy to understand are time series data, like the price of a stock over time, or a probability that the machine will be done, is another example. Another type of machine learning is unsupervised learning. It is a pattern discovery without labels. With unsupervised learning, the machines developed the algorithm without having the data labeled. So they analyzed the clusters to figure out what is normal and what is anomaly. Example algorithm including clustering. Data is not labeled, but can be divided into groups based on similarity and other measures of natural structure in the data. Example from would be organizing pictures by faces without names. Algorithms are k-means, mean shift. Another type of unsupervised learning is rule extraction. Data is used as a basis for the extraction of a propositional rules. An example is the discovery of the relationship between the purchase of a beer and the diapers, such as association rule mining algorithm. Benefits of machine learning include automation, being unbiased, and being able to improve over time. So let's look at what's the differences between machine learning and the statistical modeling. Machine learning is an algorithm that can learn from data without relying on rule-based programming. It is a subfield of computer science and AI, and is a recent development in the 1990s as steady advances in digitization and cheap computing power enable data scientists to stop building finished models and instead train the computer to do so. The extent of assumptions in machine learning. It does not need specify the distribution of dependent or independent variable in the machine learning algorithm. The types of the data. Machine learning does really well with the wide, which is high number of attributes, and the deep, which is high number of observation data. Statistical modeling is a formalization of a relationship between variables in the form of mathematical equations. It is a subfield of math, which deals with finding relationship between variables to predict an outcome being there for centuries. There's a large extent of assumptions for statistical modeling. For instance, a linear regression assumes linear relation between independent and dependent variable. Another assumption includes independence of observations. An error should be normally distributed for each value of a dependent variable. Similarly, logistic regression comes with its own set of assumptions. Even a nonlinear model has to comply to a continuous segregation boundary. Types of data. Generally applied for smaller data with less attributes, or they end up overfitting.